Hello everybody and welcome to today's video where I'm going to be doing a breakdown of how I created my Ludum Dare 46 game, which is called Keep LD Servers Alive. Of course, the theme of Ludum Dare 46 was Keep It Alive, so I thought it would be pretty funny to make a game based on keeping the Ludum Dare servers alive. Anyways, in today's video, I'm basically just going to be doing a code breakdown of kind of how I created some of these major systems in my game. As I've mentioned before, I've created this game using the data-oriented technology stack, so I could take advantage of the entity component system and some cool features like that. Now, I'm not going to be going through everything line by line, but I'm going to be going over some of the major bits of code and just kind of talk about how I created them and maybe how I could do it better next time. But if you are interested in maybe me going a little bit more in depth on some of these topics and maybe making a dedicated tutorial on any of these things, definitely let me know in the comments section below. But if you do want to play around with this project yourself, I'll include some links down in the description where you can go to my GitHub to download the source code, or I'll also have a link to the full project files if you just want to download it and have everything ready to go for you. Also, now is probably a good time to mention the Discord community that I'm currently building up. It's going to be a great place for game developers of all kinds to go to talk about game development, some of the technical aspects, as well as some of the business related aspects. And especially if you're interested in ECS development, I think that's going to be a really great place for us to all share knowledge and kind of talk about some of the issues that we're running into and really just help us become better developers overall. And as always, if you did enjoy this video, I'd really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos on Unity game development. Of course, if you have any questions or suggestions for future videos, you can leave those down in the comments section below as well. But anyways, let's jump into the breakdown of my Ludum Dare 46 game, which is called Keep LD Servers Alive. Now, I figured before I get too deep into it, I'm just going to go ahead and play some of this game real quick just to kind of give you the brief idea of what it's all like. I did make a full kind of let's play video on my channel, so I will link to that video. But basically, this is kind of the Ludum Dare server here in the middle, this little black box. And then we can click on this little uplink here, and then we can collect these red dots, which are supposed to represent game jam games. And then basically what happens is we can kind of move this little collector thing around and basically send these games to the Ludum Dare server for processing. And then you see, as we start to actually send games to the server, then you see our server load increases here. And then of course, as we process more and more games, then we have more money to spend. And then when we click on the Ludum Dare server, there's kind of this like server upgrade screen here. So we can maybe say increase the link speed. So we can do that. And then now the games actually move much quicker to the server than they did before. And then of course, this is just kind of like a full globe, and then there's basically games from all around the world, and we can kind of go up, down, left, right. So this is basically the kind of gist of the game, and I'm going to be showing you how I created some of the major components of it right now. Alright, so I think a good place to start would be the camera controller, because it was the first thing that I actually implemented in the game. And this camera controller is just a standard mono behavior. The few of these scripts that I'm going to be going through at the beginning are mono behaviors, and I will let you know when I start using actual systems. Basically, the idea for the camera controller is you have the whole screen, and then when you move the mouse towards one of the edges of the screen, then it's going to either rotate around the globe, or it's going to kind of go up or down. So basically, in order to achieve that effect, I kind of calculated like the percentage of like the screen zone, where if you had your mouse that it would move it left, right, up, or down. So that's mostly straightforward. It's just kind of calculating some of these values here. And then now in the update function, this is where we actually see, if we are in kind of the left zone or the right zone of the screen, how are we actually going to rotate the camera left and right around the globe. And so it's pretty simple to do. Basically, we're just setting the transform.position equal to a quaternion.axis angle. For the axis angle, we're just going to do this rotation speed value, which I've set, multiplying that by time.delta time, and then we're going to be rotating that around the vector3.up axis. And then in order to set the correct position, basically what we do is we multiply that value by transform.position minus the Earth's position, and then we add back in the Earth's position. We kind of do this right here just so if the Earth is not at exactly 0, 0, 0, which in this case it is, but if for some reason the Earth were to be at another location, then it would account for that, and basically the camera would always be circling around the globe. Now for going right, it's basically the same thing, except instead of using vector 3.up, we're using vector 3.down. And so if we just reverse that vector, then we kind of rotate around in the opposite direction. So that's mostly pretty straightforward, but the reason that I wanted to show off this is because when you go up and down, it gets a little bit more complicated. So as you can see, we're doing pretty much the same thing as before. We're doing a quaternion angle axis, passing in the rotation speed. However, this time, instead of using maybe like the left or right vector, we're using this cam vert axis, which is this value that I've calculated up here. So now the reason that we can't use like vector 3.left or vector 3.right is, let's say that we have the globe, right? And then we do vector 3.left. Now with the camera facing directly to the globe, and we go up or down around that axis, that's basically no problem. However, it starts to become an issue when we start to rotate around the globe, because now we're kind of pointing at the axis at an angle. So if we try and rotate up, it's actually not going to do that. It's going to want to rotate around this axis still. So we kind of get this like weird behavior where it doesn't really go up, and especially if we're like right in line with the axis, it's not going to go up or down at all. So in order to account for that, we basically need this axis to always be perpendicular to where the camera is pointing. So luckily that's very simple for us to calculate. So I've just created this vector 3 cam vert axis, and we calculate that by doing a vector 3.cross. So we're taking the cross product of the Earth position minus transform position. So that's basically the vector from the camera to the center of the Earth. Then we're going to do the cross product with the axis of vector 3.up. So again, that's the up axis. So the cross product basically just returns the vector that is perpendicular to both the up axis as well as the axis pointing from the camera to the Earth. And so if you think about it, you have the up axis and the camera to the Earth. No matter where we rotate, we're always going to get the perfect perpendicular axis. And now that we have that axis, then again, we just rotate around it using the quaternion angle axis. And then once we've basically set the position, the last thing that we need to do to set the rotation is we'll just do transform look at, passing in the transform of the Earth. So that's basically how the camera is always facing the Earth no matter where we have it. All right, so the next thing that I'm going to be going over is the spawner class. And this is basically what I use to spawn those little red dots all around the globe in random positions. Now you'll notice it's not just anywhere on the globe, it's only on land. And I even took it a step further than that and basically made them so they're more likely to spawn in areas of higher density population. So basically what I did to start is I just took the map of the globe, which I found online. Obviously I didn't draw that myself or anything. And then I just went into Photoshop and basically just kind of painted over all the areas that were land, all the areas that were water, and all the areas that were ice. And so from that, I basically just have this like big image that's only 3 colors. Of course, you have the white for ice, green for land, and blue for water. And that's actually the map that I used for the main menu, and that's kind of how I could get those little dots to spawn just all around in random places on the globe. But I wanted it to seem a bit more realistic, so I didn't just have like a million games spawning over in like Siberia where not really a whole lot of people live, but I wanted them to actually be spawning in more population dense areas. So I took it a step further and kind of started color coding some of the areas of higher population density and kind of medium and lower population density. And so the areas that are like red, for example, then it's really likely that one of those Game Jam games are going to spawn there on the map. So basically how this works is I just pick a random layer. So again, that's going to be like a higher population density, a medium population density, a lower population density, or just kind of like a general land area. And so again, it's going to be more likely for it to return a value from the higher population density. By the way, this doesn't take place every single frame. Basically, I'm just kind of using this here to determine if it should be spawning. I think I have it spawn a few games every second. I don't remember exactly what I set it to. So then once we have the random layer, I have this do while loop. So basically we execute all this code while it has not found a candidate. And a candidate is essentially a place that it can be placed on the map. So what it does is it finds a random position on the unit sphere, and then I basically kind of extend that out to be outside of the globe, and then basically do a raycast from that point 10 units down. So that's basically just kind of like 10 units kind of through the globe. And from that, we can actually take a look at the renderer and determine the actual pixel UV X and Y coordinates of what we found. And then using those values, I can look at my image map, which again is just the kind of primitive base, a few colors only map, and then do a .get pixel, passing in the X and Y values. And then from there, it returns a color. And then I can use that color value, and I just created this little find index from color. And so it basically takes that color, looks it up, and determines the index of the layer that that color is on. And then here I basically just kind of compare that to essentially this rand layer, which is that target layer. If it is, then set this found candidate value to true. So found candidate means that we've found a position that we can spawn it on. And then I also just have this in there where if it hasn't found anything after 50 tries, then it's going to lower it from maybe the high density population to a medium density population, just so we don't get stuck in this loop forever, just like looking for some of those high density population areas. So then anyways, once we actually found the location we want to spawn it to, we basically just spawn it there and kind of set some of those values. Pretty straightforward. You can check out some of my other videos on the channel about how to instantiate entities and set some of the values on them through mono behaviors like I am right here. All right, so the next thing I'm going to show off is a little bit of my input controller. And to be frank, there's a whole lot more than just input controlling going on here, but that's pretty much what happens during game jams, is you put kind of a lot of code in this class that doesn't really need to be in this class. And overall, this is pretty hacky how I got everything to work, but it works enough for a game jam, and that's totally fine. So I'm not going to be showing off everything. I'm only going to be showing off this show arc function. And that's basically how we can get kind of this arc from the uplink, which is that like circle that we can actually control, that we move around the map to collect all the game objects, all the way back to the Ludum Dare server. So again, it's just kind of that arc between. So I achieved that effect by essentially using a line renderer, and I divided that up into 50 different segments. And so that's how I can kind of get that smooth curved line. It's pretty simple. All that I'm doing here is basically just calculating the slurp percent, which is basically just the percentage of 0 to 1, 0 being at the position of that kind of uplink, and then 1 being at the position of the Ludum Dare server. And then using that, I can use the vector3.slurp, which is spherical linear interpolation, basically just from the start point to the Ludum Dare server position, passing in the percent. And then I do that on each value for the whole line renderer. So that's basically how I can basically mirror the globe from the uplink and then curved around the globe to wherever the Ludum Dare server is. So no matter where we are on the globe, we just get that nice curve that follows the exact curvature of the Earth. And then lastly, I just use this height modifier, which I calculate off just a simple sine wave here. And that's basically how I can get the curve to go kind of from the uplink, and then it goes actually up off the ground and then back down to the server. So that's how I can get that kind of really nice smooth curve that goes up and over. And then this is where I basically just kind of add that height modifier onto the actual height of it is set already. Now, when I was going through the development, I could kind of do some funny things. So for example, I could just click the moon to put the uplink on the moon, and then I got this like giant big curve from the moon back to the servers down on Earth, so it was pretty cool. I'll show some pictures of that here. All right, so now I'm going to be showing off the collector system. So this is where we actually start to implement some of the ECS stuff here. And so now basically what the collector system does is when we put an uplink somewhere on the map, this is how it kind of gathers all the Game Jam games kind of from the collection radius and then just brings them right into the center before it starts actually moving along the path. So this is just basically just grabbing them all into the center. And this is probably not the most efficient way to go about things, but I used an entity query to basically get all the Game Jam games, and then I created a native array of all those entities just so I could have kind of a reference to all of them. And also created native arrays for the actual translation components of all those entities, as well as the Game Jam data components of all those entities. So then here's the actual entities.forEach function, and I iterate this based off of all the collectors, which are basically all the uplinks. So normally you just start with one, but you can upgrade them to actually have 4 uplinks. So it's going to iterate through all the uplinks. And again, this is kind of where some of the inefficiency comes into play. So on each of the uplinks, it checks against all the Game Jam game entities within the world, and it basically just tests to see if it is within its collection radius there. And then if it is, it sets this is attracted value to true. And with that being true, then we can actually start to move along the path, which I'll show you how to do next. And by the way, this is only executing if the uplink is set to the can collect, if that's set to true. Basically what this means is when you click on it to move it somewhere else in the world, then this can collect variable gets set to false. And this is where we go here, and then we set all those entities that were previously attracted to false. And so that's pretty much how we can kind of get that effect where if some of these Game Jam games are moving along the path and then we clicked on the uplink to move it somewhere else, then you see that we have all the Game Jam games fly back to their original position. All right, so now here's the attractor system. Again, this is another ECS system. And so the idea here is this is basically once we have the Game Jam game collected and brought to the center, this is where the Game Jam games actually follow along the path that we've defined all the way to the Ludum Dare server. So one interesting that I came across during this Game Jam is you actually can't have a 2-dimensional native array. So I can't have a native array of native arrays. Now I wanted this, as you'll see up here, I have a list of float 3 arrays for all paths. And basically this is a reference to every single point on each of the line renderer paths across all of my uplinks. So again, you can have up to 4 uplinks in the game. So that means there's 4 different path arcs that the Game Jam games could follow. And so I tried to do a 2-dimensional native array, but it wouldn't let me. It said you can't have a native array of native arrays, unfortunately. So I had to do a little bit of a workaround, which is, not too difficult, but you basically do what's called flattening the array. So essentially, instead of making it a 2D array of this number of arrays by the length of each array, you kind of multiply that, so you kind of flatten them all out and then just make that into one long array. So that's kind of what I'm doing within this for loop here. Then when you want to access something as part of the array, you basically take the X value that you want, you multiply that by the length of a single array, and then you add in the Y value. And so that's how we can get the path index for each game. So basically what we're doing with that here is we're setting the current target, so it's just kind of the next position that the Game Jam game should be traveling to. And then here's where we basically just set the position.value plus equals time.delta time multiplied by our speed multiplied by the position. And then of course we just check if we're close to the current target. If we are, then we'll go ahead and increment the current position index. If the current position index is greater than or equal to the single array length, that means we've basically reached the end of our path. And then here is where we do the add component, adding in the delete tag here. So then the delete tag, this is kind of what I did in my rollerball tutorial video, if you've seen that. Basically, we just apply this delete tag to the entity, And then I actually have a delete system that runs every frame, and then if there's anything with a delete tag, it actually deletes the entity from the game. The reason I had to do it this way as opposed to deleting the entity just straight up from here is because I wanted to take use of parallel processing, and it wouldn't let me actually delete it through parallel processing. So I had to do this little bit of a workaround here. And then basically this last little line here in the else statement, you'll see this means if the game is not attracted. That's setting basically the target position to its spawn position, the initial position. So again, that's how when we click on the uplink and then move it somewhere else, any of the Game Jam games that were currently on the path, then they all just return to their initial location. Now I know this video is getting pretty long already, but there were a couple other new things that I did just want to mention. Right before this Game Jam, I picked up the Odin inspector off of the Unity Asset Store because there was the spring sale going on. So I was able to take advantage of that to actually create what's known as a table matrix kind of for my upgrade system, so I could keep track of the upgrade costs, the values, and the names of everything. And so I had to make this class show Odin serialized properties inspector, just had to add that attribute, as well as the Odin serialize and this table matrix tag for these 2D arrays here. And I can show you what that looks like right here. It's pretty funny. Odin kind of gave me this whole warning message saying, you know, there's a reason that Unity doesn't let you do this, but we'll let you do it anyways because we're cool. So yeah, it was super easy for me to just come in here and kind of play with some of these values. I don't think it's the most balanced game ever, but I think it's good enough for what it is. And then the last thing that I wanted to show off is just kind of some of these shader graph things that I play around with, because this is my first time ever using shader graph, and I don't think I came up with the most crazy complex thing, but if you do just kind of want to see how I did it, basically this is how I achieved that effect of the 0101s kind of scrolling across on the data line. Basically you just take the time and you multiply that by a scroll speed value, and then with the tiling and offset, I put that scroll speed into the offset, tiling into tiling, which is just kind of like a public vector2 variable, so I could kind of play around with the tiling a little bit. Pass that into the UV of my texture. Of course I have just this kind of standard data line texture here, and then passing the RGBA values into the albedo of the PBR master. And then doing a very similar thing with the data capsule, which is actually that, you know, thing that's kind of gathering all those entities, but this time I'm just putting kind of like a little bit of a diagonal offset onto it. All right, so anyways, that's basically how I created this game, Keep LD Servers Alive. Those are kind of some of the major systems that I've created in it and kind of how they worked. Again, if you do want some more details on anything, or if you think I should make a tutorial video on any of these concepts, definitely let me know. Of course, if you have any questions or you want to chat a little bit more about game development, I think going to the Discord community that I'm building up right now would be a really good place for that. I'll have a link down in the description for that. Of course, if you found this video helpful and you enjoyed it, make sure you hit that like button. Also, feel free to subscribe to the channel for lots more videos on features in the Unity game engine. And of course, you can leave any questions or suggestions for future videos down in the comments section below. And don't forget, you can download the source code or project files for this project using the link in the description below, so you can kind of jump in there, play around with things yourself, and kind of see exactly how I made everything. But anyways, I hope you have a fantastic rest of your day, and I'll see you in the next one.